just that. So let's say example 4, limit of g of x and y equal to x squared over x squared plus y squared, and evaluate limit of x and y approaching 0 and 0 of g of x and y. So let's go with one path that approaches 0 and 0 as and so that could be path x and x basically. So let's go along path x equal to y or y equal to x. That means you replace y by x in here, and so the parameterization is with respect to x, and then you plug in x in here to find the g of x and x. So g of x and x is x squared divided by 2x squared. That is 1/2. So the limit is 1/2. Now how about along x equal to negative y? Again, plug in. This time parameterization is x and negative x. And so you plug in and you end up with 1/2 again, because negative x to the power 2 is x squared. And basically, and yes, negative x over here to power 2 is x squared. And so you end up with the same answer. Is it true that this function has a limit as x and y approach 0 and 0? No, actually it's not true. Here, a third path that tells you that it's not true. So let's have y, let's approach from parameterized curve y equal to 0. That's actually the x-axis. So what you plug in is x and 0. And the limit is going to be x squared over x squared, which is 1. And these two are not the same as this one. And therefore, the limit does not exist. So just because you found two that have limits doesn't mean the limits exist. And so here's the picture of this one. And you can see that at some points there are creases on the curve as we approach 0 and 0, and those creases sometimes go to 1/2, sometimes go to 1. Now let's look at the link and see what it gives us. Okay, so this is the graph of it in GeoGebra, and you can see that as we're approaching through y equal to 0, it becomes 1 as we're approaching y equal to x or y equal to negative x. It's smaller, and basically you can show as you're approaching one direction, you get one value, and this is the y equal to x or y equal to negative x, and you get other values. So different creases will give you a different value basically, or different parameterization will give you different value. And then you can see at x equal to 0, which is the y-axis, you approach 0. At y equal to 0, which is the x-axis, you approach 1, and then the other two are somewhere in between, and so there's no limit in there. It looks less disturbed, but different calculation basically has less or more bearing on the computation.